Good morning, sir. Myself N. Devi. I am from ECE. My roll number is 2340180 and my topic is operating point and DC load lines. My subject code is 23ECE302. Introduction to operating points. The operating point is the specific point on the output characteristics of a device. It represents the conditions under which a circuit or device functions optimally. Understanding the operating point is essential for analyzing circuit behavior. Next, we can go through the definition of DC load line. The DC load line is graphically representation of all possible operating points for a circuit. It is drawn on the output characteristic curve of a device such as transistor. The load line reflects the relationship between voltage and current in a circuit. Next, we can go through the importance of the load line. The load line helps to identify the operating point of a circuit under given conditions. It aids in visualizing how changes in load affect performance. Proper load line analysis ensures stable and efficient circuit operation. Next, we can go through the drawing the DC load line. To draw the DC load line, identify the maximum and minimum voltage and current values. Connect these points on the output characteristics curve to form a straight line. The intersection of the load line and characteristic curve indicates the operating point. Next, characteristics of the operating point. The operating point is influenced by the both passive and active components in the circuits. It can shift due to variations in temperature, component tolerances and supply voltage. Choosing the right operating point is critical for linearly and distortion in amplifiers. Next, we can go through the Q point in transistors. The Q point is a specific type of operating point in amplifiers. It represents the DC biasing condition under no input signal. Proper Q point placements ensure linear amplification and minimal distortion. Next, analyzing load line intersection. The intersection of the load line with the characteristic curve defines the operating point. This intersection determines the circuit behavior under varying loads. Analyzing this point allows for optimization of curve performance. Next, we can go through the effects of load line shifts. Shifts in the load line can occur due to the changes in the load resistance. A higher resistance will move the load line upwards, affecting the operating point. Understanding these shifts help predict circuit response to different conditions. Next, we can go through the example for DC load line. Common emitter configuration. A common emitter transistor amplifier is a common example for load line analysis. The DC load line is plotted using the collector current and voltage characteristics. The Q point is determined based on desired amplification and distortion levels. Next, AC load line considerations. The AC load line is used to analyze circuit behavior under AC signals. It must be considered alongside the DC load line for comprehensive analysis. Both load lines helps in understanding signal fidelity and amplification range. Next, operating points in other devices. Operating points are relevant in various devices including diodes and operational amplifiers. Each device has its unique configuration that indicates the load line shape. Properly setting the operating point is crucial for the intended application. Stability of operating points. Stability of the operating points is essential for reliable circuit operation. Feedback mechanisms are often implemented to maintain stability. understanding the influence of temperature and component changes is critical. Practical applications of load lines. Load line analysis is widely used in designing audio amplifiers and RF circuits. Engineers rely on load line to ensure desired performance specifications are met. Load lines are also help in troubleshooting faulty circuits by identifying operating points. Common mistakes in load line analysis. Misinterpreting the characteristic curve can lead to incorrect operating point selection. Neglecting temperature effects may result in unstable circuit performance. Failing to consider the impact of load changes can affect circuit reliability. Conclusion and key points. The operating point and DC load lines are vital concepts in circuit analysis. Proper understanding and analysis leads to optimal circuit design and performance. Continuous learning and applications of these principles are essential for effective engineering. Thank you, sir.